All right, we are talking about slope and equations of lines, basically, here. The first thing we want to discuss is slope. Slope is just the rate of change between two quantities. You should have seen this before. So you can write it a couple different ways. So again, it's the rate of change between two quantities. And you can do the change in y, so y2 minus y1 over the change in x, x2 minus x1. Some people write delta y, that triangle represents delta. That's the change in y over the change in x. Or you can just think of it at the rise over the run. There's different kind of slopes. You could have positive slopes, whereas the x is increasing, the line is going up. You could have a negative slope, whereas when the x is increasing, the line is going down. Zero slope is just it's a horizontal line. An undefined slope is vertical, as a vertical line. In this particular case, there's no run, so there's nothing, it's not running in any direction, it's just all rise. All right, so if you want to find the slope here, you would just do, it doesn't really matter which one you pick up, to x1, y1, or x2, y2. You can do this one first, that one first, just keep the order the same. So if I do 2 minus negative 2, and then I'm going to have 4 minus negative 2. So 2 minus a negative 2 is 4. 4 minus a negative 2 is 6. So I get positive 2/3 for my slope. All right, if you go ahead, try the next one on your own. You can check the answers on the filled-in note sheets. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So when you're asked to find the slope of the following lines, if it's not in y equals mx plus b, rearrange it. So if I want to get y by itself, I subtract 3x from both sides. Now, ideally, I want the x first, so I'm going to say 2y is equal to minus 3x plus 1. I still got to get that y by itself, so I'm going to divide both sides by 2. And then the slope now I can say is negative 3 over 2. This right here, where it says ax plus by equals c, this is called standard form. But again, we can rearrange this. So we want to solve for y. So I'm going to have negative, so by is equal to negative ax plus c. Divide everything by b. So then the slope here is negative a over b. All right, when it says to graph it, the easiest thing to do is graph the y-intercept first and then use the slope. So the rise is 1. The run is 3. Rise 1, run 3. All right, so that would be the graph of that line. All right, the y-intercept is the point at which the line crosses the y-axis. So x is equal to 0. The x-intercept is the point at which the line crosses the x-axis, so y equals 0. All right, so then what we have, well, we also are going to do another type of equation here. It's called point-slope form. So it says the line through x1, y1 with slope m has the following equation. Y minus y1 equals mx minus x1. Basically, just like with your other equation, some of these things are going to be variables. So this and this are still going to be variables. Everything else you should be able to plug in numbers. So right here, if you notice, here's my variable, here's my variable. There's my slope, just like I said it was up here. And then here's the y, here's the x. So over here, the point 4, see that subtraction there? Subtraction there. So then I have a positive 4 for my x coordinate. Subtraction here, so then I have a positive 2 for my y coordinate. So I'm going to graph the point 4, 2, and then I'm going to use the slope. And this one's negative, so it's got to go down. So the rise, or in this case, is a decline, and then over 3. Right, and then there's that graph. What's nice about point slope form is that you can use the equation if you're just given a slope and a point. So to write the equation, I would just do y minus my y value, which in this case is a negative 2. So it's y minus a negative 2, or y plus 2. I put the slope, and then x minus 4. Now, if you had to write it as y equals mx plus b, so let's say you wanted to put it in slope-intercept form. So if you wanted to put it in a slope-intercept form, you would first distribute that. I got to get y by itself, so I'm going to subtract 2. And that would be slope-intercept form, okay? Again, if I'm just leaving it in point slope, it's pretty easy. So y minus y1 equals the slope x minus x1. All right, here, if you're given 2 points, no matter what equation you use, so, oops, sorry, this one right here. So this one is just y minus 8 equals negative 3 x minus 0. Obviously, x minus 0 is just x. So you have y minus 8, negative 3 x. And actually, I probably should just write negative 3x. I don't need that parenthesis. Let's get rid of it. All right, so now down here. Now we're given 2 equations. So up here we were given the slope and the point. No, sorry, now we're given 2 points. So no matter what equation we use, we have y equals mx plus b, and then we have point slope, y minus y1 equals mx minus x1. No matter which equation that we use, we always need a slope. So no matter what, you're always going to have to calculate the slope. So let's say I calculate the slope for this first. So I'm going to do 2 minus 0 over negative 3 minus 5. Even though negative's down there, it doesn't matter. I can just put it in front like that. So y minus, now, sorry. So I got the slope, and I have a point. So I might as well just use point slope. That's the easiest way to do this. So I'm going to do y minus, it doesn't really matter which one I pick. So y minus 0 equals negative 1 over 4 x minus 5. Again, y minus 0 is just y. So that could be my answer. Now, you could have picked the other point. So you could say y minus 2 equals negative 1/4 x minus a negative 3, so it makes it x plus 3. Okay, either one of those would work. The thing is, too, what you need to think about, or what you should realize, if I wrote this as point at slope-intercept, I would end up with, that's not going to work. I'd end up with y equals negative 4x. So then I distribute that negative 4 to the negative 5, so I'd get positive 5 over 4. Down here, if I distributed the negative 4, I have negative 4x, and then I'd have minus 3/4. I would add 2 to both sides. Y equals negative 4x. So this is negative 3/4 plus 2. 2 is the same thing as 8/4. So negative 3/4 plus 8/4, I'd get 5/4. Okay? So it didn't matter which point I selected from up here. In the end, I still get the same answer if I change it to point slope. No, sorry, if I change it to slope intercept. Point slope, you're going to see something a little bit different. All right, you can try this one and look at the answer in the filled-in notes. All right, we talked about this a little bit on the first page. Sometime you're going to get standard form. If you see standard form is ax plus by equals c. A, b, and c are integers, and a is greater than or equal to 0, so it's supposed to be positive. If you started off with this one and you had to graph, the easiest way to do this is to use the intercepts. So right here it says graph 10x plus 5y equals 40. Yes, I know you could change this to slope intercept, but the point here is how to graph it using the intercepts. So the x-intercept, where we cross the x-axis, is when y is equal to 0. So basically, I'm going to take this equation and plug in 0 for y. So I get x equals 4. So the point 4, 0 is on this line. For the y-intercept, that's where it crosses the y-axis. I want to set x equal to 0. So 10 times 0 plus 5y equals 40. This is obviously 0. 5y is equal to 40. Y is equal to 8. So the point 0, 8 is on this line. And I can connect those 2 points, and there's my line. Okay? All right, the last thing in this section is parallel lines and perpendicular lines. If you have two non-vertical lines, if two non-vertical lines are parallel, then their slopes are equal. If the slopes of two distinct non-vertical lines are equal, then the lines are parallel. So that's just the converse. Any two vertical lines or horizontal lines are parallel. So if we have two horizontal lines, they're going to be parallel. Two vertical lines are going to be parallel. Okay? Perpendicular. If two non-vertical lines are perpendicular, then the product of their slope is -1. If the slopes of two lines have a product of -1, then the lines are perpendicular. Any horizontal line and any vertical line are perpendicular. All right, this product of their slopes being -1. You'll also hear this called opposite reciprocals. So 2 and -1/2. If I multiply those together, and -1. -4 and 1/4. If I multiply those together at -1. 2/3 and -3/2. If I multiply those together, I get -1. Okay? All right, let's just talk about a couple things here. All right, a horizontal line this way. Horizontal line. The equations for those is just like, as an example, y equals 4. It's y equals some number. I just picked 4 here. Basically, y equals 4 is this whole line. So I can pick any number for x, but the y is always going to be 4. Vertical line, sorry, and then on the horizontal line, the slope is 0. So if you think about rise divided by run, the rise is 0, the run is forever. So 0 over anything is just 0. So that's why your slope is 0. You got your vertical line. So let's say x equals 3 here. So this is a vertical, goes up and down. So x is always going to be 3, and then y is going to be any number. In this one, your slope is undefined. So in this one, the rise goes on forever, but the run is 0. You can't divide by 0, so that's undefined. Okay? So any horizontal line has a slope of 0. Any vertical line has an undefined slope. All right, parallel lines, the slopes are equal, but the y-intercepts will not be equal. They'll be different. They're going to cross the y-axis a different place. If you have perpendicular lines, the slopes are going to be opposite reciprocals. And of course, the y-intercepts are going to be different, okay? So then we can use this idea to help us write out equations. So write an equation of the line through 5, -3, and perpendicular to 4. So this slope right here is 4 for this equation. It's already in slope-intercept, y equals mx plus b, so I just can take out the slope. This would mean the perpendicular slope is going to be -1/4, that opposite reciprocal. All right, if I want to go through that point, so I have a slope and a point, the easiest way to write the equation is using point slope. So y minus this y1 here, so -3, so it's +3, and then the slope, and then x minus 5. All right, if you had to write this in slope-intercept, so you distribute there. I'd subtract the 3 from both sides. So if I subtract 3, that's like having 12/4, and it's negative though because I'm subtracting, so -7/4. So if you had to write it in slope-intercept, that's the answer. You might just be able to leave it in point slope, and that would be the answer. If I didn't want to make them perpendicular, but I wanted to make them parallel, then I could just leave the slope the same. And I could say that y plus 3 equals 4x minus 5. And again, if I wanted to rewrite this in slope-intercept, it might be fine to leave the answer like that. But if I wanted to rewrite it, I'd distribute the 4, subtract the 3, and that would be my answer in slope-intercept. Like I said, it might be okay to leave it in point slope. Depends on what the question asks. Let me grab a calculator and just show you what these look like on the calculator. Just wanted to show you what the graph of these lines look like. So my original line is this 4x plus 1. And my perpendicular line is this -1/4, which is 0.25, x minus 7 divided by 4. And then this parallel line that I created is 4x minus 23. Don't worry, you don't have to be able to graph any of these with your calculator. I just wanted to show you what's happening here. So there's the first line. There's the perpendicular line. And then there's the parallel line, okay? The perpendicular line may not look like 90-degree angles, but it's just because of the screen, the pixels on the screen, okay? There's the original, perpendicular, parallel. And if you notice here, if I look at the table, they are, well, the second two both go through the 0.5, -3. because that's how I set it up. Okay, pretty cool. All right, we will discuss any questions tomorrow.